Okay, let's start. Okay, so if you look at these two pictures, now, even though they're meant to be funny, they do have a couple points in mind. And when you look at that little inchworm, he's not going to be an inchworm anymore, right? So obviously he might be an 1.5-inch worm. No, because he's getting stretched. Well, yeah, right. So he would be 1/2 inch worm. Probably a 0-inch worm after that. The point that this is trying to make is that there's a lot of things that exist that if we use them long enough, their ability to measure decreases. Okay? So if you use like a yardstick, every day, the numbers could rub off. Humidity, like if it's wooden, wood expands, contracts. If you've ever used like a torque wrench, when you tighten bolts, often you should only tighten bolts so much. If you tighten them too much, you either break the bolt or you break the cast that it's going into. So they'll tell you to do it to 20 foot-pounds. And so I have a wrench that it actually clicks. Like you can have some that have a meter or whatever, but you set it to 20, and then when you're tightening it, it'll go click, and that's enough. Okay? All of your, when tires are put on, every bolt or nuts in that case would be tightened to maybe 90 foot-pounds. Now 70, they'd probably fall off down the road. 100, 110, you wouldn't be able to get them off if you were stranded in the middle of nowhere and you're trying to get this bolt off with this little wrench. And it's maybe too tight, it could actually break the bolt. Because if you want, you can just keep tightening stuff until it breaks, right, if your wrench is long enough. But what if your torque wrench gets out of calibration, where now it's actually doing 100 and it's supposed to be 90? Then you'd be over tightening. Okay? The second one is what we're going to talk about next, and this guy's complaining that his hot dog, look how small it is, and it says foot-long hot dogs right on the top, right? And he's like, okay, look at my foot, right? Because that is what he refers to as a foot. So that kind of gets us into the first thing that we're going to talk about, and that's reference. Not reference like on a resume, but reference. And that is an item used as a measuring unit in estimating. Okay? So if you're estimating, what would how long would you say that is? Yes? No, you could put referent on your study sheet, right? If that was asked, or if I said, what would be the referent here? And you're like, crap, I don't know what a referent is. That means you missed that point, right? Pardon? Yeah, but don't do it right now. Do it kind of after the notes when you're going through and doing the homework and stuff. You want to do the notes now, and then you're going to summarize your own notes on the study sheet. Okay? If I can get through this without my computer. Okay. Now, a referent, again, is something that you use as a unit of estimating. So, I want you to forget any measurement you've ever learned. Okay? And not only do I want you to forget every type of measurement or every unit you've ever learned, I want you to even ignore it. When I ask you, what would you come up with if you were doing your own measurement system? What would you use as a referent for things that are small? Okay, so just put up your hand. What would you use? You're starting a whole new measurement system, and you're not allowed to use anything that anyone has ever used before. For something that is small, what would you use? Yes? A dime. Okay. So if you use like a dime, right? And if you said, yeah, it's about 4 dimes long, it is a way to be able to communicate with somebody that they're like, oh, okay, yeah, that's about right. Yeah, I'd say that too. Okay, that's good. How about something that's medium? Mm, no, we want to talk about something maybe the length of a desk or something. Yeah? Yeah? Yeah, you could. You could use desk widths, right? Now, you guys understand that not only are you making an assumption about what medium is, I can guarantee you all you guys had a different idea of what a medium-sized object is. But then with that, after you have that assumption, you make another assumption that people even know what a desk width is to measure maybe the length of this room, right? Like if you're saying, yeah, the length of the room is like about, I don't know, say 20 desk widths, right? Two things you have to know is that they understand that's a medium-sized object, because some people, well, I thought a medium-sized object would be a desk. So then I would use like, hand spans or something like that, right? So now let's talk about a large thing. Okay, and again, don't yell it out. What would be something that you would use as a referent for large things? To measure the length of I'm going to tell you what that is, because you have to make your own assumption. What's in a large thing? Yes? What would you? Yeah, school buses. Okay. How big? Have you guys ever been in the Butterdome? You could use you could put a school bus in there. You wouldn't even see it. Look like a little thing in there. Okay. I've been in there where they pull a big semi in. You could put like, I don't know, 40 semis in there, right? 50 semis. So you could say, yeah, people, hey, everyone's rode a yellow bus, but maybe it is a way to communicate. So bus widths, right? Okay. Those are called reference, you guys. They are something that you have used, and you guys have all done it. Okay. I don't know, a couple car lengths, we've done it, right? So we have used something that's not a standard measurement, like it's not universal, but we still use it. That's a reference. Now, we know that somebody's come up with some other ones, and there's two systems that we study. The first one is Imperial. That is what U.S. uses, except for their military. Their military and the rest of the world is in metric. Now, what's another word used as a synonym for the metric system? Anyone remember from all the way back to their junior high years? They are called disunits. Yeah? Yeah, that's what it includes. Meters, kilometers, all that. What is the name of that system? Yes? No. It's a good try. Yeah? No. It's all tens, but it actually has a name. It's French. Have you ever heard of SI units? System International. Yeah. Okay. So these are also called metric. They are SI units. Okay. And you're going to do a lot of that stuff in physics, right? Now, we're doing 2 lessons today, so we're going to keep moving forward. Let's just go down here. Okay. Now, I just want to, right off the bat, I haven't given you anything like that. In metric, what would you use to measure your height? Just yell it out. Meters. Meters or centimeters, right? How about imperial? Feet or inches? A wallet photograph. Some of you guys have no idea what that is, but there was a time where people took pictures and put them in their wallet. Here's my kids. Yeah. So a wallet photograph, what would you measure that in? Oh, that shouldn't have been in millimeters, sorry. Centimeters or millimeters? How about Imperial? Okay, what does Imperial have that's smaller than inches? They do, with fractions. Everybody's favorite. Hey, fractions, common denominators. Woo-hoo. Yes, we will be doing some of that. Okay, the distance between two towns. Kilometers and miles, all right. I had a student named Miles and I called him kilometer once and he didn't get it. He didn't think that was very funny. It's one of those dark math jokes. The length of a driveway. Imperial? Feet or yards, yes. Okay, how about go all the way down to a thickness of a book? Thickness, yeah, centimeters or millimeters, right? And Imperial? Inches. Okay, and like, what would you say in Imperial, the thickness of a piece of paper? An eighth? A thousandth of an inch, yeah. You always have to say it as a fraction. 1/64th of an inch. Yep. You do. It's just, you know what? People only want to have so much up in their head. That's how they do it. So they're like, okay, I'm good with meters and centimeters. Decameters, they're never used. Hectometers, actually, hectares are when all fields, like farmers, will do it in hectares, right? But no, a quarter is, I used to know all that. I actually grew up in a farm, so I used to know all that. But by a quarter mile, isn't it? Right. But is it a mile by a mile is a quarter? Or is that a section? What's a section? A quarter by a quarter. So a section must be 1 mile by 1 mile. There you go. That'll be on your test. Okay. Let's just go past this page. Boom. And look at us. We're on day 1 continued, aka day 2. Yep. Time flies for us, right? This would have been done in 2 days if you were just a regular 10C. Mm-hmm. Well, they'd go out and measure stuff, sit under trees and talk how much they love math. But we just know. Okay? Uh-oh. I chose. That one's already done. You guys don't want my done notes? Okay, now you will notice the beginning of this lesson, if it ever opens. I did have all this ready, but my computer did crash on me. Okay, so basically, here are 2 jokes that have nothing to do with math, but they're kind of funny. The second one's not funny at all to me, but the first one, I get it. It says if we pull this off, we'll eat like kings. Mm-hmm. Okay. Let's talk about the metric system. Now, the metric system, here it is, System International de Units. Okay, so a European system, and it is so nice to use because it's all base 10. When you're switching in Imperial, like 1 foot equals 12 centimeters, or 12 inches. And you're like, okay. Like, when you look at all the conversions or whatever, there is no real sense to it. It's just kind of like, I believe that probably the foot was the first measurement ever used, and then they built on that. Well, what should we, like, how should we divide up the foot, right? And it went from there, right? Because the, the yard is 3 feet. Okay, so that's maybe too much of a coincidence that it's a nice 3. When you're dividing down, like if they started with the inch, I think they would have went 10 inches as a foot, right? And they would have went that way. So anyway, that's just what I think. I could be 100% wrong, but now 1 inch. How many centimeters is an inch? We're going to do a few conversions here from imperial to metric. Yeah, it's 2.54. Good. Now, do you see? Okay, ladies. Do you see that there's a dot above the equal sign because it's not exactly equal? It's also written like this. That is, well, it's similar or very close to. Okay. Now, 1 foot is how many centimeters? You know the ruler. 30. Good. 30 centimeters. Now, 1 yard is really. No, well, I got 90, but if you're converting, you're probably more accurate. I'm just doing close to. And 1 yard would be 0.9 meters. 1 mile, that's 4 times around a track. 1,600 meters, yeah. So they call that the 1,600 meter now. Okay, now if we're going the other way, these are very hard to kind of just know, but 1 centimeter would be 0.4 inches. 1 meter would be 39. Okay, just ignore this one. Okay. No, sorry. Don't ignore that one. 1 meter would be 3 feet, 3 inches. Okay, now I want you to ignore the other one. That's for real this time. No, wait a minute, don't. Just kidding. Okay, so 1 kilometer is 1,100 yards. And 1 kilometer is 0.6 miles. Now, if I was to give you this kind of question in the exam, I would in the question say, well, 1 kilometer equals 1,100 yards. So, blah, blah, blah. That, of course, would not be something you'd have to memorize. Okay, now, I don't like this at all. Bad, right? What conversion produce smaller numbers? I mean, that's just something to memorize, and it doesn't really make sense, right? But there is a nice way to remember how to get through all of your metric system. Okay? So there is the K, H, D, B, D. So this is actually DA, just so if you want to put that there. Well, kilometers and hectometers, for some reason, always use a capital. But they don't always use a capital. So I put it because it could be lowercase or uppercase on those two. Okay? So how do you guys have these memorized? You don't? Didn't you guys do these like in junior high? Oh, really? Okay. Awesome. Okay. So this is how I memorize it. It is a little dark, okay? But it works. It stays in my head very good, okay? So, because I write this down every time I do a conversion, okay? So it's, kill him dead, but don't commit murder.
It's impossible.
You get somebody else to do it. So, kill him dead, but don't commit murder. Okay? Now, here are the... So, yeah, there's an A in dead, so that's how you'll remember. Decameter. Okay? The other one is decimeter. So here are... Now, this stands for base. It is all of the things in the metric system that do not have prefixes. An example would be the meter. The meter is the base. It has all the prefixes put on it, right? Kilometer, hectometer, decameter, decimeter, centimeter, millimeter, okay? It's all based on the M. So B is general for all of the other things. What else do we know in the metric system? What other types of measurements? How about like mass? Kilograms would be, right? So the gram, so you have the kilogram, hectogram, decagram, decigram, centigram, milligram. Okay? Okay? What else? Very good. The liter, the kiloliter, hectoliter, decaliter, deciliter, centiliter, milliliter. Anything else? Think back to science. What else? Force is newtons. Yes, very good. I didn't do that in the last class. Forgot about that. The newton, the kilonewton, hectoliter, decalewton, decilewton, centinewton, and millinewton. Yeah, seriously. Yes, watts. Very good. Kilowatts, right? You've heard of kilowatts. What? What else? There's more. Yep, kilojoule, right? That's 1,000 joules. That's a lot of money. Pressure is newtons. Yeah, pascals. Very good, yes. Kilopascal. Holy, we had a list of 3 in the last class. You guys are on fire. Still missing the one. You're going to kill yourself. You're like, oh, I can't believe I didn't think of that. Pounds is Imperial. No, moles isn't. Yeah, just milliamps. Yeah, amps would work. There's the milliamp. Okay, I'm going to give you mine. The second. The millisecond, the... I know you guys should be disgusted with yourselves. Okay, so now I just want to please get you to write down the prefix. This is kilo. Okay, then it's hecta. Or hecto, sorry. Deca. Okay, this is our base. Deci. DECI, milli, no, sorry, centi, then milli. Okay, we'll get to that actually. Because the micro, 1, 2, 3, this is like, I'm going to do it above the line, but it's like a U, like a, kind of like a U that's turned backwards, a longer tail, that's micro. And if you go 3 more, then it's the N, and that's the nano. Now, that's not part of it, but it's just kind of good for more interest when you get to your sciences, right? Yep. Base, which, yeah, you're going that way. Base, deci, centi, milli. So, kill him dead, but don't commit murder. Okay? Now, the metric system is so nice to use if you have this chart down all the time, because converting from one to the other is simply just like counting how many you have to go on that. Okay, so let's head to the next page. Okay, So here's two examples. The newspaper reported that the measurement is from Earth to the Moon is 38,440,300,000 centimeters. And a worm measures 0.0019 meters. Now, those would be called inappropriate units. Okay? Because it's like, what? Like, really? What? Centimeters to the moon? Why'd you do that? Okay? What would be a better unit for distance to the moon? Kilometers, yeah. Light years is actually a different, okay? So, yeah. Okay. So we're going to go to kilometers. Okay, so everybody's with me again. I'm going to keep the chatting down, please. Now, this is what you need to do. If you need to convert from centimeters to kilometers, all you do is you go kill him dead, but don't commit murder. You circle where you are right now. We are at centimeters. And all you do is you count how many places you're going to go to kilometers. Now you don't count where you are. You count like steps, right? So it's 1, 2, 3, 4, 5. So we have to go 5 places. Now right now, where is the decimal? It is right here, correct? So write your decimal there. All I want you to do is move your decimal 1, 2, 3, 4, 5. And that would be 384,403 kilometers. It's just that easy. So, I said I'm not a big fan of memorization, but to memorize that chart, just that kill and don't commit murder, it just helps you so much. I'm not asking you to, okay guys, whenever we go from centimeters to kilometers, it's 6, okay? Or it's 5. It's 5, okay? Remember it's 5. Write that down somewhere. It's always 5. And you're like, oh crap, centimeters. Is that 5? I mean, I know it's 40 here. Like, that's too much. But we get our base thing in there, and then we use it every time. So I just write it down every time, okay? Now, it takes longer maybe than someone that's memorized it, but I can do it 10 years from now. Someone that's memorized it, I bet you 10 days later, they couldn't tell it to me again. They might have got it regurgitated on the test, but they can't keep doing it, okay? Now, a worm measures 0.019 meters. Now, what would be better for a worm? Yeah, millimeters. Yeah, so let's pick millimeters. So we're going to go to millimeters. So kill him dead, but don't commit murder. Now circle where you are. We are at base. I'm going to millimeters, so I'm going to go 1, 2, 3. Now always pay attention where your decimal is. Right now my decimal is there, and I am going to go 1, 2, 3. It's a pretty small worm. He is 1.9 millimeters. It must be just a little baby worm. Okay? Is this, yeah. Wouldn't want to run into that in the dark alley. Is this making sense? How to do this? Okay? Now, I'm going to teach you what is the most important skill that you need to get through chem and physics. Okay? So, bear with me as we go through this because you guys are new at it. But this makes your life so much easier. And all of your physics that you take in science this year, hopefully your teacher's teaching you how to do this because it makes your life so much easier. Now, kilometers to meters. We already know how to do it on the chart. Easy, right? But I'm going to show you another way that even though it may seem more difficult than the chart, it'll teach you some concepts. Okay. Now, if I have 30 kilometers, I want to multiply it by something, so it gives me something meters. Okay? Now, everybody knows that this is the same thing as 30 over 1, right? Now, does everybody know that when you multiply numerator by numerator to get the numerator, denominator times denominator equals denominator. You don't have to do any common denominators or anything like that. So here's the trick. We have to serve two masters here. Number one, I've got to get rid of kilometers, like the unit kilometers, and I got to get meters there. Number two, I can only multiply this thing by the number 1. Because if I multiplied it by 2, well, what? 30 kilometers, like, why'd you just multiply it by 2, right? So, and right now some of you guys are looking at me crazy. When do you multiply by 1? Okay, so this is what I'm trying to say. I'm going to talk about the units first. When you have kilometers on the top in the numerator, how's the only way to get rid of it? Divide. Or put kilometers on the bottom. That's the same thing. Now, do you see how when those two multiply, the kilometers will cancel? What do we need to get left with? So if I put meters on top, do you see now? Kilometers would cancel and I'd be left with meters. Now give me a true statement that equals 1 up there. So what am I talking about? 1. I'm going to put a fraction in here. And this fraction has to equal 1. Yep. Perfect. Okay. 1,000 meters equals 1 kilometer. Okay? So I did two things here. First of all, get the units down. Why did I pick those? I needed kilometers to cancel. I needed meters to stay. Then I filled in the correct number. And do you agree that this equals 1? 1,000 meters over 1 kilometer equals 1. So I haven't, when you multiply anything by 1, do you change its value? No. So I've multiplied by 1 to change its units. Okay, that's it. So kilometers cancels with kilometers, and 30 times 1,000 is 30,000. Now, if I was in your spot right now, I'm going, that is way harder. I like that charty thing that we just, okay? And if it was me on a test, it's like show all your work. I'd show all my work, and then I'd check it on my little kill and dead but don't commit murder. But this has applications much farther than just converting units. It actually teaches you a lot of good stuff for physics. Okay, let's mix these up here. Let's do 3. Okay, 521 meters equals so many mil. So I'm just going to write this out. 5.21 meters times some fraction, right? And this has to equal so many millimeters. Now, first of all, who can tell me what my units will be? Okay, so put up your hand. What over what? That's the important thing. What over, no, don't yell it out. What over what? Okay, let's get a few more hands up here. What over what? Yes? Very good. Now, why did you pick that? Right, because these will cancel for sure, and then you're just left with. Now, I need a true statement that equals 1. Okay, who can give me that? Yes? It's not a million. I think you got kilometers mixed. Because here's meters, and here's milli. Yeah, look. Look, 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 look. 1, we would go 1, 2, 3. 1, 2, 3, 1,000. Okay? So this is going to be 1,000 millimeters equals 1 meter. Now always say that statement to yourself, because I have students that mix up all the time and they're like, yeah, 1,000 meters to a millimeter. I'm like, really? Think about that for a sec. Okay? Don't laugh because we all do it, right? So now we do 5.21 times 1,000. So those cancel, right? And we would get 5,210 millimeters. Okay, let's do 6. 6 is one that we haven't kind of done yet. 40.7 decameters. So I just write it again underneath, DAM, times something has to equal something kilometers. Okay? So first of all, hands up, what would my units be? Okay, don't yell it out. What would my units be? Okay, and who cares if you make a mistake? Yes. Decameters over kilometer. But my decameters can't. Look, if I did this, would they cancel? No. And those are good things. Just write it down. Go, oh, that doesn't look right. Like, don't memorize it. Write it down. And then, because I know that this should always be the same as the top. And this should always be the one I want to keep. Now I need a true statement. Mm-hmm. 100 decameters in 1 kilometer. So now I'm going to go 40.7 divided by 100, which gives me 0.407. Okay, now let's go over to this. Now let's work with squared and cubed. Okay, so let's do this one, and then I'm going to show you a trick how to do these like awesome easy. But this is how the units cancel. So we have 3 centimeters squared times something equals something meters squared. Now, what you do is just put a square outside like that. This is how you're going to do your conversion. Now, what would my units be inside? So put your meters up top and your centimeters below. Now we're safe inside the brackets. When I'm safe inside the brackets, I can do my true conversion. What would be the number you would put in there that would make this equal 1? Yes? 1 meter is 100 centimeters. Now, do you see that when you bring the squared in, that would make that meter squared over centimeter squared, right? If you bring this squared in, you bring it into everything. So that would actually be, I'm going to write down 3 centimeters squared times 1 centimeter squared over 10,000 centimeters squared. 100 times 100. Yeah, because 100 times 10. Yeah, so all I did was square that entire thing. times 100, right? Okay, and that gives me, see, centimeter squared cancels centimeter squared, so 3 divided by 10,000 is 0.0003. So it's the same thing, but you put brackets squared, okay, and then do it just like you always did it. Now, the way that I do it is I go, kill him dead, but do commit murder. I am at centimeters. I am going to meters. So then I just go 2, 4. So I'm going to move it over 1, 2, 3, 4. And if it's cubed, you go by. Remember, you heard it here. Okay? So, let's just do this one here. If I was going from meters cubed to decimeters, now it's decimeters, so we're going right. Decameters is left. Don't get those confused. That's the end. So then I just go, kill him dead, but don't commit murder. Okay, I am at basic. I am going to this one. So I will move 3 decimal places. Yeah. So we're going to go 3. So that would be 1, 2, 3. So put in 2, so 4,700 decimeters cubed. Okay? See, these are the things you want to write down on your study sheet. Right? When you're going from, if it's squared, go 2 every time. When it's cubed, go 3 every time. Now, you may not forget that tomorrow. But remember, when we're doing a final exam at the end of the year, do you think you're going to remember that? Do you think if you just read your study sheet over once, you get it all back? See, my hope for you is at the end of the year, you only have 7 pieces of paper with everything you need to know on it. Staple that together, and you've got the entire course on there. And you've already used those study sheets. You studied off them. You got to use them for every quiz. You got to even use some of them on your exams. It's not this big thing of notes in your textbook and you got to go through it all again. You got to try and what did we learn, right? So what it really, really saves you time on is the end of the year. For the time you put into doing that study sheet, has a guy beside you right now going, oh man, that's so much work. I'm doing so better off not doing that work. Wait till the end of the year and see who has more work. Okay, now, come on, let me get through this. Okay, the imperial system, we already talked about that. And here are some very common ones. 1 foot equals 12 inches, 1 yard equals 33 feet or 36 inches, and 1 mile equals 1760 yards or 5,280 feet. Now this is on your formula sheet. You don't have to have those memorized, but you need to know how to use them. So what I was teaching you before will help you really good with Imperial. Okay? So here is a polar bear. Mine is in color. Yours is not. That's the way it is. Life isn't fair. So they took this picture and they said the scale is 1 to 24. Okay? Now, that is saying, okay, that bear is a lot bigger in real life, right? So 1 something on the, they said imperial distance. So you'll need a ruler, but so this, if I gave you this problem on a test, and I said this is 3.5 inches. Now, I know it's not. Looking up there, it looks pretty big, but on yours, that's what it is, real. And this is 5.4 centimeters. Okay. It says calculate the height of the bear's back to the nearest inch. How would you do that? Okay, so we know 5.4 centimeters. We want to multiply it by something, so I am left with something inches. Okay? What would my units be for sure before I even start this? Inches on top, right? Centimeters on the bottom. Now I need a true statement there. Either how many centimeters to an inch or how many inches to a centimeter. Right? Does that make sense? What I've done there? Is that a true statement? Is 1 inch 2.54 centimeters? So I've multiplied it by 1. That's cool. And my units cancel. So I just have to go 5.4 times 1 divided by 2.54. And you get 2.1258 inches. Now, why did I go to so many decimal places? Yeah, never round until the final answer. Yeah, that was 5.4 centimeters. Now, how would I find out how tall that bear is really? Multiply it by, how did I get 2.12? Because when you take 5.4 times it by 1, but then you divide by 2.54, right? Because it's on the bottom. So when you multiply by 24, because that's the scale, you get 51 inches. Okay? We're rounding at that point. So we're not going to finish this problem. We'll just keep going. Okay? Now at the bottom, when you convert from Imperial to another, it usually involves what we call unit analysis. Unit analysis, that's the same thing as canceling. Okay? Let's cancel units we want to get rid of and add units that we need to finish this with. Okay? Oh, what happened there? Okay. So 4 feet is how many inches? Now, instead of, now you all have your formula sheet on you, but I want to, 4 feet, I want to multiply by something, which equals, now I need units first. I need, what units am I going to use? Top is inch, bottom is feet. Okay, now I need a true statement here that equals 1. Okay, and say it to yourself first, because people confuse these things, right? They're like, yeah, 12 feet to an inch, all good. Okay, and they go with it. Now, the units cancel, and 4 times 12 is 48. So you may have learned a different way of doing it, and it's actually seems simpler, but it's more confusing when it comes to doing some hard stuff when you get going in physics and stuff. Unit canceling is what saved me in physics. Because you would multiply all these things together, and you know how you knew you got it right? Because all the units cancel and you got grams and it was asking for mass, right? Like it was your verification. If everything canceled and you had milliliters, you'd be like, okay, I screwed up somewhere. You could find it, right? Now let's do one mile is how many feet? So we're going to multiply by, what would be the units?
1 mile would be feet.
Okay, feet and miles. Now we need a true statement. 5,280 is 1 mile. Now I see how miles will cancel, so that would just be your answer. 5280. Okay. 4 is a good one because it's going to take 2 parts to be able to get rid of. So, do we have a, look above, do we have a miles to inches? No. So I don't want you skipping any steps and doing some calculation in the corner of your page and then coming back down. Let's see if you can show how this works. So I'm starting with 14 miles. And since I don't have it above, but I know I have 2, so we're going to multiply by something, and that will leave me with something inches. Now let's just get rid of miles first with something above. What would you use? Feet, okay? So feet would go up top, miles on the bottom. 5 to 80 would go there to 1 mile. Now, does everybody see that miles would cancel? But now I'm left with feet. My answer should not be in feet. So I'm going to do another step to get rid of feet. Okay, but I need to know with what? What would be my units? Inch over foot. Okay, and what would I put?
It gives us 12 to 1.
12 inches is 1 foot. Now, see how foot cancels with that one? So all you do is you multiply all these together and you will get your answer in inches, which is 887,040. I know you guys know how to multiply in your calculator, so I'm not going to waste your time. Okay, and then all of these you should just kind of know now. 12 inches is 3 feet. Okay, 1 miles, how many feet? And 1 yard is
36 inches.
36 inches. Okay, so you have the rest of the time to work on assignment 1. Oops. All the way to page 11. So bottom of page 11. 20 minutes. Okay, go grab one if you have one. Okay, top drawer, right hand side.